Hello everyone, welcome back to another new video. In this video, we are going to solve a numerical problem of plastic moment capacity. Okay, so such type of question is repeatedly asking in our final examination. So this one are very important. Okay, it's a point of university examination. Okay, so in this question you can see here we have a given question, given a frame. Okay, and in this frame we have a two fixed support 8 point A and 8 point D. We have two fixed support. Okay, and in the question you can see here in question we have to determine the plastic moment capacity. We have to determine plastic moment capacity of the given frame. Okay, and assume same section is used throughout. It means the value of EI or the value of I is same. There is no change. So this AB is also I, this BC is also I, and CD is also I. So the section is same throughout. Okay, there is no change in EI. So this is given in the question, and we have to calculate the plastic moment capacity. Okay, so you can see here if you see to the loads, then we have a two different loads. You can see this first one is 20 kilometer load is applied over here, and second load is this 50 kilometer load. Okay, this 50 kilometer load acting vertically. Okay, vertically from up to down. So due to this 50 kilometer load, this beam will deflect like this. Okay, so in this case this will be BC will be our beam mechanism. Okay, and in another we have another load that is 20 kilometer. Due to this 20 kilometer, you can see here this beam will sway like this. Okay, sway like this. So due to this 20 kilometer, here will be sway mechanism. So due to this 50 beam mechanism, due to this 20 kilometer sway mechanism, and after combining these two, beam mechanism and sway mechanism, we have to find out combined mechanism. So in overall you can see here we have to deal with the three different mechanism. First one is beam mechanism, second one is sway mechanism, and third one will be combined mechanism. In combined mechanism we have to find out the plastic moment by the combining this beam mechanism and sway mechanism. So now let's go to the solution. Okay, so if you are new to the channel, please do like, share and subscribe the channel. Okay, and you can visit in playlist. There is so many videos related to our civil engineering, so you can go and watch all those important videos. Okay, so now let's move to the solution. In very first we have a beam mechanism. Okay, so for beam mechanism we need to take consideration of this vertical load, that is 50 kilometer. Okay, so this 50 kilometer load acting in this BC portion. Okay, so you can see here this load is acting 2 meter from this C side. Okay, so it means total is 4 meter, here is 2, so the remaining portion is 2 meter. So it means this 50 kilometer is acting on this center of this BC span. So it can be written as, here you can see here, this, as I said, this beam will be deflect like this. So this will be over here, you can see this is like this, and due to here is a load of light 50 kilonewton. So due to this deflection delta will occur over here. Okay, and the distance is, this is 2 meter and 2 meter in the given question, and due to this is the same distance, you can see this is also 2 and this is also 2. That's why here the angle formation, this theta will be same. It means uh, this theta will be equal to this theta, and this theta will equal to this theta. Okay, because length is the same. Whenever length is same, we have to take same angle. Okay, so now you can see here in given triangle you can see Okay, in right angle triangle, you can see here. Okay, suppose we are going to take this right angle triangle. In right angle triangle, tan theta, tan theta is nearly equal to theta, which is equal to p by b. P means this delta p upon b. B means this 2. So from here, delta can be written as 2 theta. So delta equal to how much? 2 theta. Okay, from here we can write delta equal to 2 times theta. Now we need to calculate internal work done and external work done. Okay, so first calculate the external work done. Okay, this will be easier. First we have calculated from right angle triangle delta equal to 2 theta, and for the external work done we just need to multiply this load by the deflection. The load is 50 and 50 into this delta, so external work done means 50 into delta. Okay, in the place of delta we can write 2 theta, so we have written 2 theta. So external work done will be our 100 theta. Now we need to calculate the internal work done. So for the internal work done, the value of MP is same for this whole entire section. Okay, whenever there is different value, that is suppose this is 3 MP, this will be given 3 MP, this will be given MP. In this case we have to take the lesser value. Okay, but in this question we have the same value MP, so this is for this point B our MP, this is MP and this is also MP. So for the external work done, you can see here. For this point B, we have to take MP into this theta, MP into theta. Okay. For this section, the point C, for this point C, MP into this theta, so MP into theta. And here you can see here, this is also MP, and here two different theta, that is theta and this theta. So theta plus theta into this MP. So in this way, we can calculate the internal work done. So this will be 2 MP theta to MP theta, and this will be MP theta, MP theta. So in overall, you can see here we have 1 and 2 and 1, total 4 MP theta. Okay, so internal work done will be 4 MP theta, and in external work done will be 100 theta. Now, as we know, internal work done equal to external work done. So 4 MP theta equals to 100 theta, and from here we get the value of MP is 25 kilometers. Similarly, let's move in the second step. Our second step will be sway mechanism. Okay, so in sway mechanism you can see here, as I said, the sway mechanism occur due to this horizontal load, that is 20 kilometer load. Okay, so due to this 20 kilometer load, initially our beam is like this. Okay, our beam is like this, and due to this horizontal load, the beam will deflect like this, sway like this. Okay, beam will sway like this. Okay, so due to this, our new beam can be seen like this. Here you can see A to B, B to C, and C to D. Okay, the value of MP is same, so this is for MP, 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 and MP. There is no changes. Okay, and in this case, for the show mechanism, we have a different theta. Okay, in above we have seen length will be same, length was same, so theta was also same. But in this case, vertical lengths are different. You can see here in our question. Okay, this is 4 meter. Okay, and this is 6 meter. It means our angle during the sway mechanism, our theta will be also different. Okay, due to 4 theta 1, and due to this 6 our angle will be theta 2. So now see in the figure. Okay, so our frame sway like this, and initially our frame is like this, so we have shown this by the dotted line. Okay, so now you can see here, due to this 20 kilometer, the beam deflected by delta 1 in this portion. Okay, and delta 2 in right side portion, you can see here. Okay, now for the external work, we have to calculate internal work done and external work done. So it is very simple. For the external work done, we have to just multiply this this 20 by this delta 1. So external work done can be written as 20 into theta 1. See here, okay, 20 into theta 1. And for the internal work done, we have to take mp into theta 1 for this point A, mp into theta 1. For this point B, mp into theta 1, mp into theta 1. And for this point C, mp into delta 2. Okay, so okay, due to this mp into theta 2, so mp into theta 2. And at point D, mp into theta 2, so mp into theta 2. So in overall we can see here, in right angle triangle we can write the value of theta in terms of delta. Okay, so in right angle triangle here you can see theta or theta 1 or tan theta 1 can be written as p by b. P means delta 1 upon b means how much, this value. This value is 4 meters, so 4. So delta 1 can be written as 4 theta 1. Okay, delta equal to 4 theta 1. It means in the place of delta we can write 4 theta 1. Okay, so this one is delta 1. So you can see here. And similarly for right angle triangle this, we can write this is also theta 1. Okay, due to this 20 kilometer, this beam will be sway at a same deflection. You can say this is delta 1 also, and this will be also delta 1. So due to this, for delta 1 we can also write delta 1 equal to p upon b. P means uh, no, this is theta 2 means in this right angle triangle you can see this is also delta 1. Okay, not delta 2. So delta 1 can be written for this p by b. So p means, so this theta 2 can be calculated nearly equal to tan theta, and this will be delta 1. This is delta 1, delta 1 p by b. B means you can see here this is 6. So the value of delta 1 can be written as 6 theta 2. 6 theta 2, it can be written as 6 theta 2. Okay, so in the place of delta 1 due to external load we can write 6 theta 2. Okay, so this 20 into 6 theta 2, finally we get 120 theta 2. Okay, and now for the internal work done, we have already discussed about this portion. Now we have to just take the value of this theta 2 in the place of theta 1 in place of theta 2. So theta in the case of theta 1, this is for the theta 2, and for this theta 1 we have written delta 1 upon 4. So it means delta 1 equal to 4 times theta 1. So delta 1 can be written as 4 theta. From this right angle triangle we get delta 1 equal to 4 theta 1. From this right angle triangle we get delta 1 equal to 6 theta 1. From here we can see theta 1 will be equals to 1.5 times theta 2. So in the place of theta 1 we can add 1.5 theta 2. So this theta 1 can be written as 1.5 theta 2. This theta 1 can be written as 1.5 theta 2, and this is already in theta 2 terms. So 1 1 2 theta mp theta 2. So by adding these three value we get 5 mp theta 2. So now we need to equal these three value. Internal work done is equal to external work done. So this value will be equal to this value. So a 5 mp theta 2 equal to 120 theta 2. Okay, so from here this theta 2 will be cancelled out. Okay, and the value of mp can be written as 120 by 5 means 24 kilonewton. Okay, so the value of mp 24 kilometers from this beam sway mechanism. Okay, and from beam mechanism we get the value of MP, that is 20 kilometer. So we calculate two different value. Now let's move for the combined mechanism. In step number 3 we have to deal with the combined mechanism. So for this combined mechanism we have to take two different load in consideration. Okay, so for this vertical load, this beam will deflect like this, and this will be beam mechanism, and due to this 20 kilometer load, here will be shear mechanism, and this will be deflect like this. Okay, so in this case we have two different load. This one is 50 kilometer vertical load, okay, and this horizontal load, that is 20 kilometer. So in this case you can see here we have external work done due to two different load. You can see here, due to this 20 into delta 1, okay, this one portion, and due to this 50 kilometer, 50 into this delta. Okay, so due to vertical load, okay, the deflection will be delta, and due to this horizontal load, deflection will be delta 1. Okay, so total external work can be written as 20 into 4 theta 1. In the place of delta 1 can be written 4 theta 1 and delta 2 theta 2. So in overall we get external work done is 180 kilo theta 1. Okay, and this is also, this theta 1 can be written as 4 times theta 1. Okay, and this is 6 meter. Okay, this is 6 meter. So theta 2 can be written as this delta will be equals to, this is also delta 1 and this is also delta, not delta 2, this is delta 1. So this is 6 theta 2. So from here we can write this theta 1 can be written as 0.67 times theta 2. Okay, so from here you can see here, this is MP into theta 1. So MP into theta 1, this is MP into theta 1 also. So we have take MP into theta 1. Okay, so first remove this, then you can easily understand. Okay, so for the internal work done, you can see here, in this case, this is theta 1, so this is theta 1, here this will be same, and here in this case this is written mistake here. Okay, this is just make it correction, this is delta 1 and this theta 1 is theta 2, not 1, this is 2. In the place of delta 2 we have to write here delta 1, and in the place of theta 1 we have to write here theta 2. Okay, so after this you can see here, this one will be MP into theta, because in the MP this theta 1 angle make over here, so MP into theta, due to this MP into theta 2, MP into theta 2. Okay, and due to this point B we have a two different angle, that is theta 1 and theta 1. So this will be MP into theta 1 plus theta 1, same, this both are the same, theta 1 plus theta 2. No, no, not 2, this is 1. Okay, because these two angle are theta 1, so theta 1 plus theta 1, so this value becomes 2 theta 1. Okay, because this is also theta 1, not 2. Okay, and for this section you can see here, for this point C we have also this MP into theta 2 plus theta 2, this both are the theta 2 and theta 2. Okay, and for this point this will be MP into theta 1 plus theta 2, MP into theta 1 plus theta 2, you can see here this portion. Okay, so this will be same, theta 1 and theta 1, so this will be 2 theta 1, and the value of MP theta 1, and in the place of theta 2 we can written as, in the place of this we can write 0.67 theta 1 and MP theta 2. So from here theta 2 can be written 0.67 theta 1. So after adding this all the value we get 5.34 MP theta 1. Okay, so now we have to equate these two value. So from here internal work done equal to external work done. So you can see here we get the internal work done, that is 5.34 MP, and external work done 180 theta 1. So finally equating, we get the value MP is 33.7 kilometer. So from here you can see here we get three different value from three different mechanism. Okay, from combined mechanism 33.7. Okay, you can see here from combined 33.7, and from you can see here from beam mechanism we get 25, and from sway mechanism we get 24. So 25, 24, and 33. Okay, we get three different value: 24, 25, and 33.7. So from here we have to take the highest value. So the larger value is in this combined mechanism, that is 33. First one was 25, second plastic moment was 24, and third one is 33.7. So we have to take the highest value, that is 33.7. So plastic moment will be 33.7 kilometer, and this is our required plastic movement capacity. So in this way we can calculate plastic movement capacity, and this question will be very important. And in next video we will see the next problem. Thank you very much. Thanks for watching. Stay connected. Please do like, share, and subscribe the channel.